coordinates of the vertices of each image. So if we look at A, what kind of transformation are we doing in A? Reflection. But how do we know it's a translation? Very good. You're adding and you're subtracting. That's a good indicator that you're doing a translation. So to get the new vertices, let's follow that rule. If it's x plus 3, which direction are we moving? Good, to the right 3 units. So each point, we're going to start with x goes to the right 3. That's y minus 1. Which direction are we going? Down 2, down 1. Again, label your points. Right? Do that with every single point. Or every single vertex. Right 3, 1, 2, 3. Down 1 and label A prime. 1, 2, 3, down 1. B prime. 1, 2, 3, down 1. H prime. Okay, and then connect. If you have this similar question on your test, and it told you to do a translation, and you translated the figure, and then you moved on to the next one, are you going to get full credit, or if any credit? No, because what does it say to do in the directions? Yeah, list the coordinates, so you have to list your new coordinates. So what did we get for M prime? 1, 1. What did we get for A prime? -1. What did we get for T prime? 3, -5. What do we get for H prime? -1, -3. Okay, there you go. Then you get full credit. You list it all. Okay. Questions over that? Oh. Take a look at B. What kind of transformation are we doing in B? How do we know we're doing dilation? We're multiplying 7 by x, and we're multiplying 7 by y. So that's telling you you're doing a dilation. Okay? So again, when you do a dilation, it's telling you what to do right there. You multiply your x values by 7, you multiply your y values by 7. When you do a dilation, you have to write down those original points. When we write down those original points, m is -2, 2. A is 3, 0. T is 0, -4. And H is -4, -2. Right? You have to write down those original points when you do a dilation and rotation. For fractions and translations, you're just counting, so you don't necessarily have to write them down. Okay? And again, all we're doing, multiplying your x and y values by 7. So you're going to get a new point. You're going to get M prime. You're going to get A prime, T prime, and H prime. You're going to make sure you label as well. Labeling is important. What do we get when we multiply M by 7? What's our M prime going to be? What is -2 times 7? -14. What's 2 times 7? 14. It's not going to fit on our grid. No, that's okay. We're not worried about graphing it. We just want to know what the new coordinates are. What do we get when we multiply this point by 7? What do we get? 21, 0. What do we get when we multiply t by 7? 0, negative 28. And what do we get when we multiply h by 7? Again, we're not concerned with them fitting. We just want to know what the new points are. There you go. Let's say you could also, with translations, you can write down what the original points are, and then you could have added 3 to your x value, so negative 2 plus 3 is 1, and subtracted 1 from all your y values, so 2 minus 1 is 1. That's also an option. Write down the originals and just add and subtract whatever it's telling you to do. That's another way. Okay, questions over that? Yeah. We take a look at 2. Yeah, I don't know how it fell down there. I gotta fix that. If we look at 2, we want to do the following transformations and this is 5 minutes. Sorry. Oh, there we go. Driving ball. Okay. You didn't notice it? Oh, I was gonna sing it. The lid was like swaying in front and causing a shadow and driving us. Okay. So what kind of transformation are we doing in A? What kind of transformation are we doing? How do we know it's a reflection? Yeah, capital R. What are we reflecting over? What line? X equals negative 2. So you're going to go where x is negative 2. Which direction are we going to draw that line? Are we going to draw up and down or horizontal? Up and down. Very good. It's really tempting because we think x is always horizontal. But if you drew the line horizontally like this way, you're touching every single x value. We only want to touch the x value of negative 2. So it's going to go vertical. Then kind of opposite of the direction that axis goes. Okay? Now if we reflect, again we just count. So how far is A away from that line of reflection? 5. So we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's okay if it goes off a little bit. That will happen. How far is A away from that line of reflection? 1, 2. You go 1, 2. In the other direction. How far is T away? 2. So 1, 2. How far is M away from that line of reflection? How far is M? Yes, right on. It's 0. So is M going to move at all? No, when that happens, you still need to relabel that point as M prime. And then you just connect. Just flipped it over that line. Questions over that one? We look at B. What kind of transformation are we doing in B? Rotation. How do we know it's a rotation? Little r. Okay, or what degree are we rotating it by? 90. Okay, always assume it's counterclockwise unless you're told otherwise. So again, with rotation, you have to write down those original points. So the same one as the first problem. I'm going to rewrite them. 3, 0. 1, negative 4. Right? No. That's 0, negative 4. And h is negative 4, negative 2. Sometimes these graphs are really hard to read where the axis is. So it helps if you have like a highlighter, go ahead and darken them. If you're having a hard time finding them, that's okay to ask. I'd rather you know where the axis is so you get the right answer than you not ask. You don't use the right axis because you just can't tell where it's at, and then you get points taken off. So if you're having a hard time on your test on Thursday and you're like, just axis, is this the axis? I'm happy to like darken it for you. That way you can just do the problem here, right? Okay? If that is an issue, just let us know. Clarify for you. Okay. So when we do a 90-degree rotation, what happens to the point? Flips. Very good. So we're going to flip this point. Comes to -2, 0, 3, -4, 0, and -2, -4. Then what happens? Do we change the sign of the first or the sign of the second with a 90-degree rotation? First. So the +2 becomes negative. Is there a sign to change with 0? Just leave it as 0. The -4 becomes a +4, and then -2 becomes a +2. And then you just plot your new points. Again, make sure you label. There we go. Questions over that? Okay. We take a look at C. What's that first transformation we're doing? Yeah, how do we know it's translation? Capital T. Are we moving across at all? Why? Yeah, because there's a 0. Your horizontal movement going right or left always has to go first. That's always coming first. That's the first number written. Okay? If you get them flip-flop, you're going to get the wrong answer. So make sure horizontal movement, the movement of the x is always first. And you notice there's a 0. So you're not going to move across at all. Which direction are we moving? Up. It's a +2, so we're just going to move each point up 2. Do that first. And up 2, that's A. Up 2, that's T. Up 2, that's H. Right. And I like to do that because that's not our final image. We just split that figure up. And we're not done yet. This is why it's super important to label your final image because everything's going to be laying on top of one another and it's going to look super messy. That's why we like you to label with prime. So we know what is what. Now we don't lose points. What's the next transformation we have to do? Taylor?
Before we do the next translation, what do we name the points?
I just, like with the first one, if there's more than one, I just rename them what their original ones were. And then when you do the second one, that's where you're going to use your primes. Yep, good question. What's our second transformation? Flexion over y-axis. We're going to highlight that y-axis. And you just count. 1, 2, 1, 2, M prime. 1, 2, 3, 1, 2, 3. A prime. 1, 2, 3, 4. 1, 2, 3, 4. H prime, and is T going to move at all? Why? Right on that line you're reflecting over, but you still need to darken it and relabel as T prime. Now connect with nice solid lines. You have your prime marks written. It'll be so much easier for us to grade. If we can't read what's going on, you're just going to lose points. You can't figure it out. Everything's all on top of one another. So make sure you label with primes for the final image. Make it known that that's what the final image is. Okay. Questions over there? Now we get it down. I don't need more time. For 3A, it says a line segment has endpoints with coordinates 1, 4, and 5, 8. If the segment is reflected over the y-axis, then reflected over the x-axis, what are the coordinates of the endpoints of the resulting segment? Well, we talked about this before. What is the same kind of transformation if you reflect over the x and then reflect over the y, or vice versa? When you reflect over each axis, that's the same as doing what kind of transformation? Jason? Caitlin? Yeah, very good. When you have a double reflection over your axis, so you reflect over the x, reflect over the y, or vice versa, it's the same thing as a 180-degree rotation. Okay? Well, what happens to your points when you do a 180-degree rotation? Yeah, just the signs. Do we flip the point at all? No. So if we look at our original points, we have 1, 4. We flip those signs, it's going to become what? 1, -4. Our other endpoint is 5, 8. When we change those signs, it's going to become -5, -8. Which one matches those two? A, B, C, or D? Okay. If you don't remember that double reflection like that is a 180-degree rotation, you could have just drawn your own kind of axis, your own coordinate plane. And plotted the points. So we had a 1, 1, 2, 3, 4, and 5, 8. You could have done this and then reflected the line over the y-axis, so it would have been somewhere around here when you actually did the reflection, then reflected it over the x, and then relocated what those points were. Totally fine. You could have done that. Just drawn your own, did the reflection, then looked at which one matched your new points. Or save yourself a lot of work if you remember a double reflection is the same as a 180-degree rotation. Questions over that? Okay, take a look at B. So the pre-image point, xy, x is a random point, that's what that's saying, is dilated by a factor of 3 and then translated up 6 units. Which transformation also produces the image point? Okay? Well, it's really hard when you're not given numbers, right? They just give you a bunch of letters and you're supposed to figure out what the answer is. When this happens, make up your own point. So pick a point that has easy numbers. When I did this, I did 1, 2. 1's really easy to deal with, and 2's really easy to deal with. You could have done 1, 1. Right? 1, 2. So I'm going to remake this point 1, 2. Okay? Well, let's do those transformations to that point to see what our endpoint is, what our image point is. So when we have the point 1, 2, and it says dilated by a factor of 3, what are we doing to that point? Multiply by 3. So we multiply this point by 3. What's that going to turn into? 3, 6. Okay? Then we translated it up 6. So when we move something up, which value is changing, the x or the y? The y value, right? So nothing's happening to this 3 because we moved it up. We didn't move it left or right. We didn't move the x way, so that's going to stay how it is. But if we move it up 6, would we be adding or subtracting? Adding. So we're just adding it to the y. So 6 plus 6 is what? 12. So that's what this guy now is. 312. Now, if you picked 1, 1, it would have been a different answer. Doesn't matter. Okay? You just picked a random number when they just give you letters like this. You have to figure out which one's the same. Okay? Well, what we're going to do is just go through each of these to figure out what transformation will give us the same answer, 312. So we look at A. We're still dealing with that point 1, 2. We dilate it by a factor of 6. What's that point now going to become? Multiplying it by 6. What's that new point? 6/12. Right? Then it's saying translate it up 3. So you add 3 to your y value. Well, again, the x value doesn't change. That's going to stay a 6. Can we already cross out A? Yeah, it's not matching. We have a 6 for our x value. We want a 3. And when we add 3 to 12, we get 15. That point doesn't match. So that's not going to give us the same thing. Okay? Well, let's try B. Still dealing with that original point. 1, 2. Translate it up 6. Okay, so what's the next point going to become? We translate it up 6. 20. The x value doesn't change. You add 6 to the y value. Okay? Followed by a dilation of 3. Well, what do we get when we multiply that point by 3? 324. Does that match? Nope. The x value matches. Y value doesn't. Can't be beat. Right? Well, let's see if C gives us the right answer. Still dealing with that original point. We're going to dilate by a factor of 2, so we're multiplying by 2. What's that new point going to be? We multiply that 2, 4. And then we are translating it up 3. So you're adding 3 to the y value, so that new point is going to be what? 7. Because the x value stays the same. 4 plus 3 is 7. Does not match. Can't be C, so without doing any more work, what's our answer? C. Ruling all the other ones out, so I have to be E. Because when you translate it up 2, for D, that makes it 1, 4. And then when you multiply by 3, 1 times 3 is 3, 4 times 3 is 12. So it matches. Okay? Sometimes you just have to do that. Just make up your own numbers that work, pull out the wrong answer. Might take you a little bit of time, but you'll get the right answer. It takes a little bit of work. Easy stuff. Calculator again. Okay? Questions over that one? We're not done. We still have 10 minutes. Okay. Well, we're back. Number 4. So here we need to figure out what transformations map one figure onto the other. And it's kind of overwhelming at first. You're like, do we do rotation? Do we do a translation? How am I supposed to look at this and just know? Okay, what I like to do is look at the direction they're pointing. So this guy's pointing down, and this one's pointing up. Okay? And this triangle right here is pointing down, and this one's pointing up. When they're pointing in exact opposite directions, so up and down, left and right, anyone know what kind of transformation you have to do to get them to point in the same direction, Shane? Reflection. Rotations if they're pointing in different. So one's pointing down and the other one's pointing right. That's an indicator that you're doing a rotation. But if they're in exact opposite directions, it's a reflection. So we'll move this bottom one. So if it's pointing up, to get it to point down, are we going to reflect over the x-axis? Or are we going to reflect over the y-axis? Yeah, x-axis. We wanted to get it to point down. So once they're in the same direction, then it's easy. Right? So we're going to reflect over the x-axis. We do that, we just count. 1, 1. That is F. 1, 2, 3, 1, 2, 3. G. And H is already on that axis, so that's not going to move. Okay? So we flipped it over the X. Now they're pointing in the same direction. When you get them pointing in the same direction, all you have to do is slide it over to get it matched up. Which transformation is the same as a slide? translation. So how far do we have to move F over to get it in line with A? So we go to the left 3 and up 1. If we go to the left, what's the sign? Negative, so it's -3, and we went up 1, so it's positive. And it matches up. Double check all the other points. 1, 2, 3, 1 matches. 1, 2, 3, up 1. It matches, so we're good. Okay. So now we have to write those rules. Right? I'm not super concerned with the super fancy way. If you can just tell us the rules and which shape you moved using those rules, we're happy. Okay? But the proper way is, what transformation did we do first? Did it? Good. So what do we use a reflection? Capital R. What do we reflect over? Good. Yeah. Then what did we do? Good. What do we use for translation? Capital D. Which direction did we move first? Good. The horizontal movement has to go first. And then we went up 1. Which triangle did we move? We moved triangle F. Okay. Questions over that one? Do one more. Okay. And if you want to make a little note to help you out, how I like to look at things is pointing in opposite, I can spell, in opposite directions. That's indicating a reflection. Okay? If it's pointing in different directions, so not necessarily opposite. So opposite would be one's pointing right and one's pointing left. Okay? If they're pointing in different directions, it would be a rotation. And when we mean different, like one's pointing up and one's pointing right. One's pointing down and one's pointing left. Left and one's pointing up. It's different, not necessarily opposite. Okay, that's a good indicator. What I think that's the hardest part. Translations are easy to tell, dilations are easy to tell. I think whether you're doing a rotation or a reflection, those are hard. So opposite directions, reflection, different directions, rotation. And then you might have to play around to figure out, well, what am I rotating it by? I have to guess and check. What am I reflecting it by? Okay. Questions over that? We'll do one more. I go to erase this so we have room to do B. Did everyone get this written down? Erase it. Okay. So look at me. We know one of the triangles big and one of the triangles small. So what is that telling us we did? Dilation. That's what I love dilations. They're easy to tell because one's big and one's small. So let's figure out let's deal with the bottom triangle. So now we're doing a dilation. What can we do to figure out the scale factor? Take the flat side, nice flat, and count. What's the distance of this flat side? 3. What's the distance of this flat side? 6. Good. So think, what do I have to multiply 3 by to get 6? 2. So we're doing a dilation of 2. That means you're multiplying each of those vertices by 2. Write them down. You can do a reflection and then the dilation, that's fine. So a lot of these, there's more than one way of going about doing this. So you might have a different way, and that's totally fine. As long as they map up, you're good. There's more than one correct answer. If it's not what I have on my key, I'll just check it. Make sure it matches. Okay? Then there's more than one way. We just trying to show you more direct way. But there's again more than one way to do this. So this point A is -2, -2. B is -1, -1. And C is +1, -2. Okay? And again, our scale factor is 2. So we're multiplying both these points by 2. So we multiply that point by 2. A prime is what? -4, -4. B prime would be what? -2, -2. And C prime is 2, -4. Okay, so go ahead and flash those points. So -4. Okay, it's helpful to highlight that axis. Sometimes it's just really hard to see. So we have -4, -4, -2, -2, and that was A, B, and C, and 2, -4. Okay. So now they're the same size. Yes. A is, here's the axis, here's the origin, 1, 2, 1, 2. Yeah, they're hard, because the axis is very fake, kind of blends in. So again, if you're unsure, just ask where the axis is, and we'll make sure you have it in the right spot. How do we get them pointing in the same direction? Are they pointing in opposite directions or different directions? Yeah, it's a reflection, because again, this guy's pointing down, this top one's pointing down, and this bottom one's pointing up. Opposite directions, do a reflection. What would we reflect over? X-axis. I'll re-highlight that and just count. 1, 2, 3, 4. 1, 2, 3, 4 matches. 1, 2, 1, 2. That one matches. 4, 1, 2, 3, 4. That one matches. So we're good. They mapped up to each other. So list those transformations. What's that first transformation we did? What do we represent a dilation with? Capital D. What was our scale factor? And then what do we do after a dilation? So capital R for reflection. X-axis. And what triangle did we do? ABC. Questions over that?